Alright, ladies and gents, for this section we're going to be talking about the graphs of these trig functions, sine, cosine, tangent, for this video. Now we just got done looking at the coordinate plane in radians, seeing what the trig functions were equal to for each radian measure. And now we're going to give the graph representation of each trig function. So instead of like the radians going in a circular motion, now they're going to be going in a linear motion. And we're going to sketch a graph based off what the evaluations are. Alright, so I basically wrote down all the radian values from each quadrant. Now I'm just going to find the sine value for each one of these radians. Well, we know the first quadrant pretty well. Okay, so we know the sine of 0 is 0, sine of pi over 6 is 1/2, sine of pi over 4 is square root of 2 over 2, square root of pi over 3 is square root of 3 over 2, and pi over 2 is 1. So I'm just going to plot those points right now. So we know 0, 0, and we know when theta is pi over 2, sine is going to be 1. So pi over 6, and it's right around here, it's going to be 1/2. Well, actually, it's not too accurate. Oops. And then square root of 2 over 2 for pi over 4. Square root of 3 over 2 for pi over 3. So far we got like that. And then 2 pi over 3 is in the second quadrant, so all these represent the second quadrant. Again, if you just look at the unit circle, you'll be able to find all these values. So sine of 2 pi over 3 is square root of 3 over 2. Sine of 3 pi over 4 is square root of 2 over 2. Sine of 5 pi over 6 is 1/2. And then sine of pi is 0. And now we're moving on to the third quadrant. Now the third quadrant, sine is always going to be negative. Okay, so again, these are all in the unit circle. Sine of 7 pi over 6 is negative 1/2. Sine of 5 pi over 4 is negative square root of 2 over 2. And so on and so forth. And I just plot them as is. And then last but not least, we have the fourth quadrant, where all these values are found in the unit circle again. Okay? So our sine function, after going around the circle the whole way, went all the way up to 1, then went down to negative 1, and it's back up to 0. Now if we continued our unit circle, so if we went into 3 pi and 4 pi, it would continue on forever in this motion. They call this a periodic function because it repeats forever. Okay? So there's the sine function. When we get to class, we'll do we'll analyze them more, I should say. But before we do that, let's talk about cosine. Now we're going to do the same deal here. Now we're going to evaluate each one of these radians from the unit circle in terms of cosine. So let's take care of the first quadrant first. Cosine of 0 is 1. Cosine pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Cosine pi over 3 is 1/2. And cosine pi over 2 is 0. So I'm just going to plot those points right here. So we got 1, 0, 3 over 2. I'm just estimating these about, don't have to be too accurate. Okay. Now we're moving on to the second quadrant, where the second quadrant, everything except for sine is negative. So here we're going to have negative answers for cosine. So negative 2 pi over 3 is going to give us a negative 1/2. 3 pi over 4 is going to give us negative square root of 2 over 2. 5 pi over 6 is going to give us negative square root of 3 over 2. And pi, we're going to get -1. Okay, third quadrant. Cosine of 7 pi over 6 is going to be third quadrant. Oh, yep, still negative. So 7 pi over 6 is going to give us negative square root of 3 over 2. 5 pi over 4 is going to give us negative square root of 2 over 2. Then negative 1/2, and 0. And last but certainly not least, we have our fourth quadrant. And this is where sine's positive again. So then we got 1/2. Again, I'm getting all these from the unit circle. And cosine's the same way as in if we would continue going around the unit circle, this will just start repeating itself. Okay? So, it looks a lot like the sine function. That's because it's very similar. It's just pretty much the sine function moved over a little bit. Okay, next up we're going to talk about tangent. Now remember tangent, we had a bunch of restricted domains because we can't divide by 0. So let's get that taken care of and then I'll set you free. Alright, let's take it step by step now. We have all quadrants labeled. First, second, third, fourth quadrant. I want to find the tangent values of each one of these. So first off, tangent of 0. Okay, tangent was y divided by x. So the x value for 0 was 1. So this is tangent of 0 is going to equal 0. Tangent of pi over 6. Square root of 3 over 3. Tangent of pi over 4 was 1. Tangent of pi over 3 was square root of 3. And tangent of pi over 2 was undefined. So since tangent's undefined at pi over 2, that means we're going to have an asymptote right there. Okay, so we have an asymptote where the function's undefined. Now I'm going to hold off on graphing these until we get a really good idea what it looks like. And I think we'll get a good idea what it looks like in here. And remember, when we found out the domain, we figured out it was odd numbers times pi over 2. So we have an asymptote at pi over 2 and one at 3 pi over 2. Because with both those spots, it's undefined. Okay, so tangent of 2 pi over 3, that's in the second quadrant, so it's going to be negative. And so it's negative square root of 3, negative 1, and then tangent of pi was 0. Yeah, let's do... Okay, so tangent of 7 pi over 6, that's in the third quadrant, so it's going to be positive. So we have square root of 3 over 3, 1, square root of 3. So our function goes from something like that. Okay. Let's do that last quadrant. I guess we can fill in our first quadrant right now. Okay. Now we got tangent of 5 pi over 3. That's in the fourth quadrant, so this is going to be negative again. So it's negative square root of 3. 7 pi over 4 is going to be negative 1. And so on and so forth. Okay, and as you can see, they're repeating. So if we were to continue our unit circle after 2 pi, you bet that it will start to repeat. It will keep going like that forever and ever. Okay? So basically the big thing I want you to take away from this video is that these trig functions are periodic, so they will repeat after a certain interval called the period. Okay? Now, I don't have any practice problems for you. I feel like this video is long enough, so I'll see you in class on Monday.